Inductive reasoning is reasoning that you do, right? Be a reasonable person based on patterns that you're seeing. So you're looking for patterns to help you figure out what the next step is, okay? So it's reasoning based on patterns that you observe. So if you look at example 1 here, it says, what is the pattern? Okay, so we're going to figure out the pattern. And what are the next 2 terms in the sequence? Are we struggling to get notes still? Are you okay? Okay, let's just wait a minute. Okay, here we go. Sorry, back at it. What is the pattern and what are the next 2 terms? You're multiplying by 3. Okay, now here's the thing. People are always like, how do you figure out what the pattern is? I always tell people, look at the second term and do something with the term in front of it. So like, for instance, 9 divided by 3 means the pattern is the opposite of that. 3 times 3 would get you 9, right? If you subtract 9 minus 3, that means you're adding 6 in the pattern. But take the term, the next term, and do something to the term in front of it, and that will help you figure out what it is you're multiplying by, dividing by, adding or subtracting. So in this case, we are multiplying by 3. Okay, so that's what I want for the pattern. You can just say times 3. So what are your next 2 terms? You can get a calculator out if that's helpful. 243, right? So it's 81 times 3 is 243. And then 243 times 3 is 729. Okay? So sometimes it's going to be numbers like that. Numbers are pretty good, typically. Sometimes it's going to be figures that you have to find a pattern that's happening. Now, here's the thing. When working with figures, you need to be very specific with me what the pattern is. So use a lot of detail, because basically what you're saying is, if I gave someone nothing and I told them this is the pattern, they should be able to draw the next thing for you, right? Without even seeing the others, draw the next thing. Well, that's not true. I guess you could say the one before it is this. So if you look at this picture, what would you say the pattern is? Yeah, Julia.
One more side to the shape inside the square.
Inside the circle, right? Okay, so something like that would be good. It's a circle with a polygon that has one more side than the previous polygon. Okay, something along those lines. So we'll say add one side to the polygon inside the circle. Okay. So when we want to write our next 2 terms, you would do oops, I forgot I still got my circle on. Okay, so you have 2 circles. What's going to be inside my first one? That second one doesn't look like a circle, does it? Sorry. How many sides inside this first circle? 6, a hexagon. So as best you can, draw a hexagon. Doesn't need to be perfect, but as good as you can make it. Something like that. Okay. So then the next one, do you know what a 7-sided polygon is called? There's 2. Triangle?
No. 7-gon.
No, octagon would be 8. 7-agon. So here's the thing. Technically, you could probably call it a 7-gon, because eventually they do 12-gon, 13-gon, 14-gon, 15-gon. But there's actually names for it.
15-gon.
Nobody knows?
No.
There's 2 names. You could call it a septagon, or you could call it a heptagon. They both work. So 7 sides. 1, 2, 3, 4, 5, 6, 7. Okay. So those would be your next 2 terms. And I'll tell you right now, on the quizzes and tests, when there's 2 terms that need to be drawn A lot of times people forget the second one. So don't forget to draw 2 pictures when you're doing the next 2 terms like that, okay? Okay, conjecture. What's a conjecture? Don't read my definition. You tell me what a conjecture is to you. If you had to say conjecture in one word, what would that one word be?
Statement.
Statement. Okay. Anybody else? I would say a conjecture is, 2 words, like an educated guess, right? It's saying, here's what I think is going to happen, even though I don't have evidence that it's going to happen, but it's a conclusion that I've reached because I'm reasoning through something. So it's a pretty good chance that the thing I think is going to happen is going to happen. A conjecture. So look at these circles, okay? What conjecture could you make about the number of regions that 20 diameters would form? So if you look at your first one, okay, how many diameters in this first circle?
2.
There's 1 diameter. How many regions are there? 2, right? 1, 2. So for 1 diameter, there's 2 regions. How many diameters in the second circle? 2 diameters. And how many regions did you get? 4. So for 2 diameters, there's 4 regions. How many diameters in the third one? 3 diameters. And how many regions did you get? 6. Okay, so knowing that, let's make a conjecture. What do you think would happen if I drew 20 diameters in a circle? How many regions would you get, Maddie? 40. What'd you do?
I would just multiply it by 2.
You just double. So our conjecture is 20 diameters would get us 40 regions. Okay. We're just doubling the process there. Okay, but now in order to make a conjecture, you have to make sure that you have enough data. You have to make sure that you have enough information that would get you there. For instance, if I said, I have 1, 2, tell me the pattern. Some of you are going to say, add 1. Some of you are going to say, multiply by 2. We don't know which one's right because we don't have enough data there, right? We don't have enough information. So you want to make sure you gather enough information with whatever it is we're talking about to be able to make a good conjecture, okay? So if you look here, it says, what would the sum of the first 30 even numbers be? Okay, so first we're going to gather some data. We're going to say, well, if we said the sum of the first even number, so 1 term, what would the sum be?
30.
No, just 1, the very first even number. 2, right? You would get a 2 there. What if I said, what's the sum of the first 2 even numbers?
6.
It's 6, right? It's 2 plus 4, which is 6. What's the sum of the first 3 even numbers?
16.
2 plus 4 plus 6 is 12, right? Okay, and then the first 4 even numbers, 2 plus 4 plus 6 plus 8 is 20. Okay, so we've gathered some data. Now we have to conjecture what we think it would be for the first 30 even numbers. Now, this one takes a little bit of effort to figure it out. Did you figure it out, Jonathan?
I think.
What do you do?
N plus number terms times 2.
N plus the number of terms times 2.
Number of terms minus 1 plus number equals number of terms times.
You're right. You're just having trouble with how you say it. Look at this, okay? For 1 term, we did 1 times 2, right? Got us 2. For the second term, we multiplied by what? By 3. 2 times 3 got us 6. For the third term, we multiplied by 4, and that got us 12. For the fourth term, we multiplied by 5, and that got us 20. So basically what you're doing is you're taking the term number times the term right after it. So the 4th term was 4 times 5. So the 15th term would be 15 times 16. So the 18th term would be 18 times 19. So the 30th term, so the first 30 even numbers would be what? 30 times 31. Okay, so our conjecture is that the sum of the first 30 even numbers would be 930. Okay? That was a little tough to come up with on your own. You got to really stop and think about what numbers you have and what's the pattern you're seeing. Questions on that? Okay. Moving right along then. Example 4 here. It says sales have decreased over the last 6 consecutive months. Make a conjecture about May. So these are actual sales of backpacks. How many were sold in November, December, January, February, March, April? They're saying make a conjecture. What do you think, based on the information you have, would be a fair amount of backpacks sold in May? What do you think? There's not a right answer.
0?
I wouldn't say 0.
8,000.
No, I'm not 8,000.
8,000 is a great estimate, right? If you're looking at what's happening here, the pattern, working our way down, would put May right here. Well, that is 8,000 backpacks. So I would say the company will likely sell, sorry, I went to cursive, around 8,000 backpacks in May. Okay, so you're just looking at the data, saying, what do we think it would be? So if you said 8,100 or 7,800, something close to 8,000, that's fine, right? Because that's about where we're ending up based on the flow that we see in the data that they gave. Okay. Okay, so that is making conjectures, right? We're making basically an educated guess based on information that's been given to us or that we find ourselves. But here's the thing. Not all conjectures are going to be true. So you always need to test them to make sure that what you think is true is actually true. If you test it and something shows up false, we say that's a counterexample. Okay, so a counterexample is an example that shows a conjecture is false, or you could say incorrect. That's considered a counterexample. So we're going to try and find some counterexamples right now. Okay, look at these 3 scenarios, and then don't say it out loud. Think it first. See if you can come up with a counterexample, and then I want you to tell your neighbor what counterexample you came up with. And again, sometimes there's multiple options for answers. So if you got a different one than your friend, that doesn't necessarily mean anything. Okay, so letter A. Don't tell all of us. Tell a neighbor. If the name of a month starts with J, it's a summer month. I want you to give me an example of where that is false. Okay, question. Is July a counterexample? No, because this part, right? If the name of a month is J, sure, July, but it's a summer month is true, right? We're not trying to make this true right now. We're trying to make this false. So if the name of a month starts with J, it's a summer month. Your counterexample is what? January. Okay, that's a counterexample. So when you give a counterexample, it's just a word or a number or it's a very brief statement. Okay, Julia.
When was August?
August is not a counterexample. So that's a great, okay, yes. For a counterexample, this part needs to be true. It's the next part that has to be false. And we'll talk more about that when we talk about if-then statements, which is coming very soon. But basically we're saying if it starts with J, so it has to start with J, right? If it starts with J, then it's a summer month. Well, January does start with J, but it's not a summer month. So January would be your counterexample here. Yeah. Okay. B. You can connect any 3 points to form a triangle. Can you find a counterexample to that? Try and draw one on your paper. How can you have 3 points that can't make a triangle? Anyone know? Yeah.
If they're in a line.
A line, yeah. If I have 3 points, 1, 2, and 3, and they're all on a straight line, I cannot make a triangle out of that, right? So that is your counterexample. Again, you don't need to put words down. Draw a picture. That's a counterexample, okay? Letter C, when you multiply a number by 2, the product is greater than the original. Tell your neighbor a counterexample to that. When you multiply a number by 2, the product is greater than the original. John Ross, what'd you come up with? Negative numbers. Okay, so a counterexample is specific. So if you say -4, okay, that's a counterexample because -4 times 2 is -8, right? This is less than the original. This says it has to be greater than the original, okay? Anyone come up with a different counter?
0.
Okay, 0 is a good one too. 0 times 2 is not greater, it's the same. There's another one. Reynard, what?
0.9.
Yeah, a fraction, right? If we do a fraction and we multiply it by 2, it gets smaller. So fractions, negatives, 0, any of those would be good counterexamples. Julia.
1, because if you multiply 1 by 2, it's 2, but that's not greater, it's equal.
But it's saying greater than the original number. So if 1 is your original number and we multiply it by 2, 2 is greater than 1. Yeah, so I see what you're saying because you're comparing it to this. But they're saying compared to the original number that we started with that we multiplied by 2. Yeah, so 1 would not work for that. Any questions on that? Okay.